Greetings everyone. My name is Utkarsh Shukla and I am currently pursuing BSc Honours Chemistry and I am studying in Kirorimal College, University of Delhi. Today I am going to present you my presentation on the topic solid phase synthesis and protein denaturation. So let's see. As we can see, the process involved in solid phase peptide synthesis. The peptide synthesis cycle, we can see deprotection coupling and peptide bond. Solid phase synthesis is a technique for building molecules, most commonly peptides, by chemically linking them one by one to an insoluble solid support or resin. This method is popular because it simplifies purification by allowing excess reagents to be washed away between steps. A typical example is solid phase peptide synthesis, where the first amino acid is attached to a resin and then successive deprotected amino acids are added in a cycle of addition, deprotection, and washing to build the desired peptide chain. Benefits Benefits compared with normal synthesis in a liquid state include high efficiency, increased simplicity and speed. The reaction can be driven to completion and high yields throughout the use of excess reagent. In this method, building blocks are protected at all reactive functional groups. The order of functional group reactions can be controlled by the order of reproduction. This method is used for the synthesis of peptides, deoxyribonucleic acid DNA, ribonucleic acid RNA, and other molecules that need to be synthesized in a certain alignment. Solid phase synthesis overview. Method used mainly for peptide synthesis. Reactants anchored to an insoluble resin. Sequential addition of protected monomers. Simplified purification after each step. High efficiency and automation. As we can see the solid phase synthesis reaction. Firstly, a molecule or compound is having a coupling, then the production is going on, and or further coupling the production cycles, we can get the synthesized product. Mechanism of solid phase synthesis: resin binding of first amino acid, the production of N terminal group, coupling with next amino acid, repetition to build a chain, final cleavage to release peptide. Applications of solid phase synthesis are very important. Peptide and oligonucleotide synthesis, drug development, biotechnology tools, combination, combinatorial chemistry, rapid library generation. So the next topic is protein denaturation. Protein denaturation is a process where a protein loses its native three-dimensional structure, including its secondary, tertiary, and quaternary structures, due to external stress like heat or chemicals, but without breaking its peptide bonds. Example, cooking an egg. Before, a raw egg white has a clear liquid appearance because the protein albumin is in a compact folded globular state. During applying heat, example boiling, provides kinetic energy that disrupts the weak bonds like hydrogen bonds, holding the albumin's folded structure together. After the albumin protein unfolds, creating a solid opaque white mass that cannot be returned to its original liquid form. This is the example of the denaturation of protein. As you can see the protein structure which is denatured. This is an example that egg is boiled. Transformation of native protein to denatured protein. Protein denaturation basics. In protein denaturations, loss of native 3D structure, primary structure remains intact, caused by disruption of non-covalent forces, leads to loss of biological activity, often reversible or irreversible. Causes of protein denaturation: heat, pH changes, organic solvents, detergents, heavy metals. These are the causes of protein denaturation. Summary. So what have we learned today? Today we have learned about solid phase synthesis and protein denaturation. Solid phase synthesis enables efficient peptide assembly. Resin support allows easy purification. Protein denaturation disrupts structure and function caused by physical or chemical factors like heat, boiling, etc., or pH changes. Key concepts in biochemistry and biotechnology. Thank you.